So my name is Jeffrey Bewley, and I am with the University of Kentucky Dairy Extension Specialist here. And I'm going to start out just kind of giving a little introduction to what we have learned about compost-bedded pack barns. There's been a team of us here at the University of Kentucky that have worked together over the last 9 years or so trying to understand this. Initially, we did not think that this was a good idea, but Joe and I went out on some farms about this time 9 years ago and learned that the farmers had figured out something that we thought was pretty neat, and we decided to explore a little bit more what the system was about and how the farmers were making it work. To start out with, I think that we need to have a basic understanding of the concept, and the compost bedded pack barn, basically it's a loose housing system with a large resting area. It's not the grandfather's bedded pack barn. I think this was at first the thing that I struggled with, was because I grew up on a dairy where we had a bedded pack barn where we just continually added new bedding, and that wasn't necessarily the best environment for cows. In this case, we're actually intensively managing a compost process, and that process helps keeps the cows dry and clean. I do think as we compare the system to stall-based facilities, cubicle-based facilities, the risks for mismanagement are a little bit higher. It's a little bit more difficult to manage the system, have to understand the system a little bit more, and pay attention to the day-to-day activities. But I actually think it's a little bit less labor, so more management, more labor than a stall-based facility. The system has really taken off around the world. A lot of the foundation work occurred at the University of Minnesota, and they had quite a few barns that were built there in the early 2000s. However, the growth of the facility was somewhat limited by an increase in sawdust availability and sawdust prices. Between 80 to 90 of these facilities. It's really taken off well and worked quite well here for our dairy producers in Kentucky, which for the most part are smaller dairy farms. Most of our farms would be in the 50 to 200 cow range. It's really now the predominant housing system in Israel. There's a large movement for more compost bedded pack barns in Brazil and Argentina. And of course, you have the groups like Paul's group there in the Netherlands and groups in Denmark and Italy that are actively researching this facility and understanding it to a better degree. And we get contacts from all over the world now trying to understand a little bit more about compost bedded pack barns, how to build them, how to manage them, and whether or not they're right decisions for individual farmers. You can see here a pretty common design that we see here in Kentucky. It's the large open resting area there with one side being a concrete feed alley. Waters are separated from the pack. So it's a fairly simple design, but commonly repeated here in the state of Kentucky. We actually have something really exciting now, I think, in that we were able to build a new compost bedded pack barn for our university facility. So that's the University of Kentucky, not the United Kingdom. But with the University of Kentucky, we now have a compost bedded pack barn. And you can see some pictures here of that facility. It's a nice research facility. We're quite excited about what new capabilities that this brings us and capabilities that it brings us in terms of understanding the compost bedded pack barn to a higher degree. But also it's been quite beneficial for us from a production perspective. After moving into this barn last April, we've seen increased milk yield, we've seen decreased somatic cell count, we've seen decreased lameness, and we've seen fewer culls than what we had seen before moving into this facility. One of the probably primary benefits of the compost bedded pack barn is what it allows cows to do in terms of rest. You can see pictures of cows here in various facilities resting in positions that they wouldn't necessarily be able to rest in if they were in a stall-based facility. So is this beneficial to the cow to be able to lay out on her side like this, to be able to stretch like this? We don't know for sure, but that certainly is an indication that animals are able to express a natural behavior. It's quite easy for cows to lay down or get up whenever they're resting without any of the restrictions that would normally have with a freestall or a cubicle. Estrus detection is quite easy in the compost bedded pack barn. The cows are more sure of their footing. So we tend to see more obvious signs of estrus, which of course helps us in terms of reproductive management. And then another nice thing about the facility is it allows us to be able to have multiple breeds, multiple sized animals within the same facility without having to worry about different sized stalls for different sized animals. When the compost bedded pack barn is managed right, then it really can provide a nice, dry, clean resting surface for the cows. And I think ultimately, from a milk quality perspective, that's probably the primary thing that we have going on here, is that the packs are dry when they're managed right, the cows are clean, therefore we don't have as high of a risk for mastitis causing bacteria. When I think about the compost bedded pack barn, here are some of the things that I think about in terms of advantages and disadvantages. First of all, I think that it provides excellent cow comfort. It is a system that is lower to invest in than a cubicle or freestall based system. It can provide good quality, and it's nice to be able to have this dry material that we have within a compost in terms of manure handling, as opposed to having more liquids. The disadvantages: sawdust availability, shavings availability, number one, and number two, it's a huge issue making sure that we have enough of the right kind of sawdust shavings to be able to put into these facilities. There are higher variable costs associated with using this barn because of the additional bedding costs. So although we may spend a little bit less money up front, we end up spending more money across time. It does require that higher management ability, like I talked about. I don't think in general it works very, very well in retrofits, and typically it will require a larger building footprint than a stall-based system because we have more square feet that we need per animal.
Jeffrey, can I ask a question?
Yes.
Okay. You make between advantages and disadvantages. And you were telling that in Minnesota it's stabilizing, and in Kentucky it's very popular. Why is there such a big difference between those two states?
I think there are a couple of reasons. One of them is that we have a less expensive sawdust supply than what they do in Minnesota. The other is, I think that we have a very short winter, and wintertime is the most difficult time to make these bedded packs work. Minnesota has a much longer winter, so there's a longer period of time where it's a bit more difficult to make them work.
Okay.
All right, so the keys to effective composting: I think we have to design the facility correctly from the outset. We need to make sure that that facility has adequate natural and mechanical ventilation. We need to make sure that we don't overstock the facility and that we stir it frequently. Most of the time, whenever we get calls for somebody that's saying that their pack is not working, it's one of those reasons that indicates why their pack is not working. We have been quite curious how the system compares to other facilities, so we did a study that just finished up last year where we compared 15 herds. 8 were compost bedded pack barns, sand freestall barns. All these herds had to be on official DHI test. We selected only low somatic cell count herds for the study, those with a somatic cell count less than 300,000, to make sure that we were working with well-managed herds in both samples. My graduate student, she went to these farms once a week for a year, and she looked at things like hygiene score. You can see here that there were no significant differences between hygiene scores between the two types of facilities. This particular graph shows there were no differences in somatic cell count between the same facilities, so we're able to obtain the same level of milk quality in a compost bedded pack barn as what we were in a cubicle or freeze barn. We look at this in terms of clinical mastitis. There's also no significant difference in clinical mastitis between those with and without a compost bedded pack barn. We even questioned our results a little bit, so we went back and we tried to find all the herds in Kentucky that had DHI records, and we based on what type of facility that they had, we were able to determine the somatic cell count averages for these different groups. And as you can see here, there really weren't a lot of differences. There are no differences between compost, freestall, or tie stall when it comes to somatic cell count. However, there were some differences with the ones that had both compost and freestall. Those that had the compost bedded pack barns for special needs cows having a lower somatic cell count, and those that had pasture having a higher somatic cell count.
Can I ask a question about
yes.
You say you between sand bedding and bedded pack barn, but is the power of your study maybe not too low? The questions of our participants.
Sure. That's a good question. That's one of the reasons I went back and looked at the larger data set to be able to understand a little bit better, but it's not a huge data set. That's correct.
Okay.
We also looked at, and we wanted to make sure we could demonstrate the connection between pack moisture content and hygiene score, and we were able to demonstrate quite clearly that as the packs become more wet, the cows become more dirty. So in the end, the keys, we think, to managing the compost, we want to make sure that we manage the barn for optimal composting. We need to make sure that we have proper milking procedures. So if there are risks associated with the compost bedded pack barn, we can help alleviate some of those risks of managing things correctly in the milking parlor. I really think that those that are in compost bedded pack barns should be using coliform mastitis vaccines. Make sure to consider cooling at the feed line and to scrape the feed alley frequently with the compost bedded pack barn. We have quite a few different resources available on the internet in terms of compost bedded pack barn design, compost bedded pack barn management, and even looking some at the compost bedded pack barn investment analysis. Well, that's all I have for this afternoon, evening.
Yeah, Jeffrey. Thank you very much for your presentation. We are looking at the participants, what questions they asked. But I had a lot of questions about your last slide. You said proper milking is important. Does that mean that mastitis can be risked in the compost bedded barn?
That certainly was always a concern. You know, these animals are going to be exposed to high levels of bacteria. So initially, that was the main reason why we weren't sure that these systems could work. So I think it's sort of an insurance plan to some degree, that we have that in our back pocket to be able to help mitigate any risks associated with what exposure that they may have. We're trying to understand the biology of what's going on a little bit more. Really don't quite understand all of that, whether it's immune function, that these animals are better able to fight off disease. There's something to do with the competition among bacteria in the compost bedded pack barn. But ultimately, I think the more we focus on milking procedures, the better we're able to manage the risks that might come from a compost bedded pack barn. And ultimately, anything that we do to manage milking procedures correctly is good anyway, so there's not really any loss there.
Okay, thank you. I won't talk too much because there is an echo there. Not from the United States, but from the Netherlands. Yeah. And can you switch off? Can you switch off, please? Maybe that helps. Okay.
Switch what?
Okay.
Microphone.
Your microphone. You were talking about. We were talking about advantages and disadvantages. And we like to ask the participants what they think about advantages and disadvantages. Yeah, the poll. Next poll. What's this? This is the question to all of the participants. What do you think are the most positive aspects of bedded pack barns? Is it animal welfare and animal health, or economics, including labor, manure quality, or environmental aspects, like emissions of ammonia, greenhouse gases? Please put on your answer. It looks like now we don't have an echo. Less echo. Okay.
That's okay now.
Jeffrey, one of the questions is that we in the Netherlands are looking very much on environmental aspects like ammonia and methane emission. Is that also an issue in your country? So this is the most of the people expect the most advantages of animal welfare, not so much on environmental aspects. Jeffrey, can you comment on that? Is that not an issue in your United States? Oh, the microphone. Sorry. Oh, Jeffrey, can you put on the microphone?
I'm going to answer that. This is
Jeffrey,
Joe.
can you put on the microphone?
I did.
Can you hear us?
Yes. One of the questions of the participants is how important are
One of the questions of the participants is how important are environment,
like ammonia emission and methane.
like ammonia and methane emission.
In the U.S., the U.S. EPA are only collecting information about ammonia emissions and are not of great concern. Primarily, the issue with environment is that dairies are a significant impact on water quality, and they are more interested in seeing systems that have less impact, and air quality is not as important except potentially from neighbors with odors.
Okay.
Okay.
We will go into
You will go into that later on.
The andere poll.
The andere poll. This was the question about the positive aspects.
Now the question
Now
is,
the question is, what do you
are
think
the
are the most negative aspects of better background?
Please give your answer. Yeah, please give an answer. Is it working, Henry? Oh yeah.
25 people voted yet, but we're still missing the half of it. Half of you, please.
Please, more people give an answer. It looked like economics. Jeffrey, can you hear me? Okay.
Yes.
Yes, it looks like that economics. It seems to be the most negative.
Looks like that economics seems to be the most negative aspect.
Does that surprise you?
Does that surprise you?
Yeah, that's not in our experience, and maybe some differences in economic conditions. But ultimately, in general, we're seeing that these barns are constructed about 3/4 per cow, the cost of a freestall barn. So it may be something to do with the construction. I think we have less of the issues with less of the issues that you see in terms of ammonia emissions control and so forth, and we tend not to have the slatted floors underneath the facilities, so there may be some differences in how the barns are constructed. We don't have concrete floors underneath the compost. And then the other thing I think could be just in general that maybe our bedding costs are a little bit lower, but in general we would consider economics probably to be one of the benefits of the system.
Because of your building,
is cheaper and the
bedding material is cheap compared to other countries.
Probably, yeah. And certainly I think our building costs are considerably less than what yours are based on previous conversations.
Okay.
Okay.
I think we go on the presentation of Jozef Taraba. Jeffrey,
Thank you very much.
Jozef, we will
hear more about
why better
tech bonds
and how to manage it.
Okay.
Building
and bedding
materials.
Yes, I got to get used to what I've got here in front of me. Okay. I'm in the Ag Engineering Department at the University of Kentucky, and as I said, Jeff and I have been working on this for about 9 years now, and we started just by walking into my office, we going out in the field and looking at a lot of the benefits that we see from actually operations. In this particular slide, when walking into a barn, one of the things that we see here is a good distribution of animals, in which the bedded area here on the right and then the feed alley on the left. When you see this kind of a distribution, something good is happening within the barn, and this is what we want to see. This barn does show some of the limitations if we don't build a structure right around the compost barn. We see some ventilation problems at the end of the barn with a wall put up, but that was primarily because air orientation and sun. And to the left, there is some blockage. So when we start talking about the compost barn, what I want to talk about is the concept and how the building and the structure go together, which is important. And I also want to go in deeper into the compost process, mostly because of how people understand it and what a lot of the literature says that I think interferes with sometimes our understanding. And I want to just talk about some of the management aspects of that compost barn. The compost bedded barn basically is a solid composted waste is an alternative management compared to what we have done in the U.S., which is primarily a semi-solid liquids in a stack pad. But one of the things it allows is a lot more flexibility in terms of managing that waste. If we build the facilities right and manage it, we may be able to store waste within a structure well beyond the 1 year that we really designed for. And this really adds flexibility when we get to disposing of it due to weather problems. And some of the other benefits that we found are improved air quality, particularly odors, and then fly reductions. But the other kind of question is still that's open is looking at the greenhouse gas issues. One of the things
Joost, can you hear me?
Yes, I can.
Yeah. There are
a lot of questions about
how to manage it in
different climates.
Low temperature,
Yes,
low temperature,
high
high
humidity.
humidity.
I think you will get
into that
Yes,
later on in the presentation.
Yes, I'll get into some of the environmental issues in terms of climate later and how that is important.
Yeah.
Okay.
But one of the things too, in relating to the seasons is the fact that we manage the bed, but we also have to build a structure around that bed that leads to success of that bed. And how that structure is constructed is also an environmental and climate issue too. One of the things when we start looking at this barn, one of the things that we found so many times is barns were basically for ventilation were constructed based on the animal heat and water production. In a lot of cases, the barns were based on cattle that were, information of 10 to 15 years ago, and cattle are producing more heat and moisture on it. But also we've got to take into account the heat and moisture that's coming from the compost bed. So this structure has to have a lot more ventilation as well as air movement in the barn for success. When we look at design considerations, one of the things is that we need to put in sufficient feed and water space for those cattle, because that is one of the more important aspects of the success of the cattle. The other thing too is providing that the feed alley and the access between the rest area and the feed alley is along that long dimension in which there are more than one entrance into the feed alley. One of the things that happens when this bed builds up and the retaining walls on the side holding in the waste is that we need to put a fence on top of that wall, because we've seen situations where cattle will fall out of the barn. The other issue is orientation of the barn. We are primarily interested in east-west orientation, primarily with the sunlight, but specific site issues are also important in terms of that. One of the other important aspects, because of that extra heat and moisture from the barn, is getting a sufficient ridge size on that. We are looking at a ridge opening of around 12.5 centimeters per 5 foot of barn width. So if we're looking at a 10-meter barn, we'd have a 25 centimeter ridge opening. Eave overhangs of about 1/3 the eave height. Concrete alleys, we want them about 4 1/4 to 5 meters wide. And it's primarily because in the feed alley, we are looking at both the waters and the feed bunk, and we really don't want to see where animals are interfering with movement in that particular area. We don't want waters within the pack. We want to separate, we want the sidewalk, particularly as a climate issue, we want sidewall curtains to really prevent cold winds and blown rain into the compost bed. We have found that dairies were a lot more successful with curtains to really reduce some of the issues of colder weather. Particularly when we get into the summertime, is having sufficient sidewall opening above the knee wall. And we're looking at between 4.5 to 5 meters opening above the knee wall. That's again getting sufficient ventilation to that barn. Another particular problem in terms of building these barns is building them for the maximum number of cows that you're going to milk during the year, not what the average is. In so many cases, we found that the peak number of cows were in the winter time, and that's really the worst time of the year to really look at in terms of managing it. We also have to look at, when we set aside the amount of area of that rest area per cow, we sort of start off at about 9.5 square meters per cow. But if we're starting to get into higher production animals of, let's say, 40 to 50 kilograms of milk per day, we may be getting upwards to about 14 to 15 square meters per cow. And the reason for that is these cows are producing, these higher producers are producing more moisture, and we need more area per cow to help evaporate the water. In terms of circulating fans, particularly when we get into heat stress conditions, but also to help improve the drying within the compost barn, we have the ceiling fans, the HVLS fans. We can get speeds on the cows of air movement up to 4 meters per second, while box panel fans, we may get up to 7 meters per second. But in terms of the compost bed, we're getting, this improves also the drying of the bed to reduce the amount of bed, particularly in some other, when we get outside.
Before you go on, I'd like to ask some questions.
Okay.
If the climate is very humid, how important is a lot of ventilation? Should your ventilation if it's very humid?
The issue when we get high humidity, the only way we can try to get improved drying, and I'm assuming your question is relative to the compost bed or for the cows. Is your question relative to the cows or the compost bed? Well, one of the things with the higher humidity areas, like into the tropical areas, the only way that we can really get cooling to the animals and dry velocity. The compost bed in and of itself is a warmer surface under which we can evaporate even under some higher environmental conditions. Okay, one of the things in looking at the management of a bed is that if we look at the ideal composting that you've learned is that we mix carbon, nitrogen, inorganics, water, and microorganisms, stir it up to add oxygen to it, and we produce water, heat, and CO2. But if we have less than ideal conditions, we can start increasing the amount of ammonia, nitrous oxide, and methane production from composting. The thing too with composting, what you've learned is, in many cases, is when we mix it up, we put it in a pile or a windrow, we go through this temperature curve in which we have a peak of temperature early on where there's a lot of activity and a lot of bacteria, and later it starts stabilizing. But in a compost barn, we're continuously adding feces and urine and bedding, and we can create a situation where the temperature is relatively stable, and we get the bacteria in this region in which it is highly diverse as compared to a windrow in composting. I want to move on. One of the aspects of getting air into the compost bed here in Kentucky and elsewhere is either we use a rototiller, which we can till to the top 15 to 20 centimeters, or a cultivator, which we can get down to 25 to 30. Religiously is that we need to till at least 2 times per day, and we do it, and this needs to be religiously done 2 times per day, because we've seen in many cases that beds are not successful when they are looking at less than twice per day. When we look at a compost bed, we have an anaerobic zone and this aerobic till zone. And the maximum temperature that we find occurs right at the bottom of the till layer, which can be up to about 50 to 60 degrees centigrade. And this is in the depth of 25 to 30 centimeters. We can have beds as deep as 120 centimeters. One of the things from greenhouse gases that we learn, particularly in this region between the aerobic and the anaerobic, this is where we see a lot of the greenhouse gases produced in terms of nitrous oxide, methane, and CO2. But as we move towards the surface, we see less and less of those gases. As they migrate to the surface, there is conversion in many cases of them. The other thing within this bed is that how the temperature changes from the surface near the ambient temperature, and the temperature rises as we get deeper. If we look at the bacteria under these conditions, what we're seeing is there's potentially in all these different temperature zones a temperature that a certain group of bacteria will grow. And we may see selective growth with depth and temperature, but when we mix it up and stir it, we'll get those mixed up and we'll get that competition between the bugs. There in the Netherlands, when we start looking at the forced air systems and forcing the air up through the bottom through the compost, we may have a different regime of temperature, and it may lead to a different bacteria that's growing.
Jeffrey, go on.
Yes.
Can I ask a question?
Sure.
It's nice to see a picture of the Netherlands. But one of the questions is, in the Netherlands, we blow our subtle air to the bedding. But in the wintertime, it's down the bedding. It's also a problem in your if you ventilate too much, the bedding cools down.
Yes, we have the in the wintertime, by cutting the air movement in the barn, we can lose the heat in a compost bed if we have too much air movement over the bed. But that's part of the reason of having sidewall curtains that we can manage to reduce that. But it is the challenge in the wintertime. But in terms of air movement outside of this cold weather, we have been encouraging the use of fans even when heat stress isn't occurring, so that we can really get good air movement. Now, in terms of...
Another question.
Sure.
Somebody asked you what about dairy cows. But do you have experience with circular cows? And how many square meters do we need? With the air?
For calves?
A cow and
A cow and calf for suckler cows.
For beef cows,
suckler
in
cows.
terms of into cow-calf management, one has to go back in and based on how much moisture is being produced in terms of the manure and urine, and that's how I base the area. The area isn't as large as what it is for a dairy cow. It's for a cow-calf pair, it may be 50% to 2/3 of what a dairy is in terms of area per cow-calf pair.
And how much is it for
How
dairy
much
cow?
is it for a dairy cow?
For about 25 kilograms of milk per day, it may be in the region of 10 to 11 square meters per cow. If you get up to around 40 kilograms of milk per day, you may be needing an area of 14 to 15 square meters per cow.
And for a suckler cow, it would be
For a suckler cow, it would.
For which cow?
suckler cow.
Suckler cow.
Suckler cow.
It's a cow.
Beef.
For a cow calf, I would say around between 50 to 60, between half to 2/3 the area of a mature dairy. But I'd have to go.
I have another question about the barn design. In our country, we have deep litter systems. That's a hole. Underground. United States, you are above.
Yes, we're in the U.S. in terms of the compost. We're about 2/3 of the manure is within the resting area, and the parlor waste and alley waste go to outdoor lagoon. And that's how we're managing it. Some people have looked at everything, and particularly down in Argentina, we've seen that the feed alley is also compost, but the management challenges are so much greater because of it's just higher and wet in moisture, so you've got to add a lot more bedding in those areas to manage them, or else they become a real muck pile. One of the things in terms of managing these compost beds is how important moisture control is. Moisture is the leading indicator of success or failure of a compost bed. The biological activity, if we're in the right range, is where we generate the heat, which helps dry the bedding. Too wet of a bedding pack reduces aeration, slows biological activity, heat generation is lower, increased compaction, and we reduce the water evaporation. In terms of controlling the moisture, if we don't evaporate the water, that's when we need to add the bedding to absorb the excess water. And as I said, moisture control is the most important. And what is that moisture that we're looking at? When we looked at the barns in Kentucky, we found that the highest temperatures were in the range of 45 to 55% moisture. But when we look at the total management range, 40 to 60% is what we recommend. And you can see in this curve to where we saw these maximum temperatures relative to moisture. But when you look at the literature, and I've seen this reading when people talk about a compost bed, well, the range is 40 to 80% for optimum composting. But the issue when we start getting above 60%, compaction by hoof pressure from the cows is above 60% is such that we compact it to the point to where we get rid of a lot of the void fractions, we get larger particle size, and so we don't get the air in there to really compost. The larger particle sizes that occur then, they reduce oxygen diffusion, heat, and reduces heat generation in larger particles when we start stirring it. And the other thing too is that microorganisms are not just on the particle surfaces, but they are interior to these particular particles. Now, the question earlier was about seasons, and Kentucky has 2 seasons, warm season and cold season, and we're in the cold season right now. Other parts of the world, they have rainy seasons and no rain, or dry seasons. And each season, you have to recognize that you have to manage the bed differently if we're going to manage that moisture. In the warm season and dry season in the tropics, you ending up having weather conditions and air that can dry the compost, so we may need little bedding. But in the rainy season or the cold season, we're going to have to manage that moisture with adding bedding. Here's just a picture of 2 different tillage tools on a bed that has around 65% moisture. And you can see with the cultivator, the big chunks, particularly at the higher moisture, which again reduces the effectiveness of composting. Here on the right with a rototiller or a power tillage tool, we see a lot smaller particles, we get a lot more void fraction, and we're going to get a much better composting result from that. And this was just a curve of what we learned. Higher moistures, bigger chunks is what we had as we got higher moisture content. Just to look at management in terms of the bed out there, and this was an experiment was down in Argentina, where I was trying to work with them to really improve their management so that they can get good temperatures and reduce bedding. In this particular barn, they were populated with high producers at 11 square meters per cow, and they were using a lot of bedding in this time and low temperatures. They started reducing the population and increasing the square footage per cow up to between 14 and 16 square meters per cow. And as the bed was beginning to, we saw temperatures increasing and bedding usage going down. And at the point where they were up to 16 square meters per cow, they were using no bedding at all to try to maintain the temperature. So again, this just shows how management area can reduce a variable cost that Jeff had talked about earlier.
Okay.
The other thing was,
question.
yeah.
How much
Additive.
sorry.
If you use sawdust,
How much do you need per cow?
how much do you need per cow
per year?
Sawdust?
per year?
This is, that's a number on the top of my head right now. Jeff is even scratching his head on it. It varies so much based on how you're managing it. When we've done studies in which we've had square footage per cow at around 12 to 13 square meters per cow, we're getting down to where we may be looking at 50 to 100 pounds per cow during the year. But when we get down to the smaller areas that we have, around 9 to 9.5 meters per cow, we may be looking at several hundred pounds of sawdust per cow per year. But it's a management issue, and the thing is do we spend it on the building a larger building, or do we spend it on the bedding? And there is a point at which the larger building could almost be paid for by the savings in the bedding.
Okay. And can you also say something about the use of additives to improve the function of compost?
I have not felt that additives are of value, because the compost has such a large population and a diverse population that you're going to have to load a tremendous amount of bacteria to really be competitive with them. And the other question is when I've dealt with additives for lagoons for improving of bacterial activity, the biggest issue is are the bacteria adapted to the environment they're being put into? And so to say whether an additive would work or not, it's a flip of the coin. So my particular perspective is management is the key and not the additives.
Okay, that's clear.
Okay, that's clear.
One of the other issues, particularly with greenhouse gases, is as we get larger particles of compost, in this particular case of methane, when we get something about 8 to 12 millimeters in diameter, we have a tremendous increase in the methane production. But another key thing that we had found out, if the pH of the compost increases, we get increasing methane production. Our compost, some composts can get up to 8.5 pH here, and so we are producing the higher amount of methane. But when we've been looking at our beds, and one in particular, we're getting pHs in the range of 8, between 8.5 to 7.5 pH. So we are at a little bit lower. If we can control, at least if we're looking at greenhouse gases, the potential of reducing the pH value is a way potentially of that occurring. You know, what we are one of the issues, and I'll show you with a little bit of ammonia here in just a bit on when we look at different beddings. It's in a couple slides when I finish up here on the bedding. We are primarily here in the U.S. look at sawdust, and we like here on the left the finer sawdust materials. Shavings on the right, they're good, but they're not as effective as having a good distribution of particles. One of the things that found, particularly in South America, because of not enough sawdust available, really looking at a lot of different alternatives. Rice hulls, and if you finally ground particularly soybean straw, wheat straw, corn stover, miscanthus, sorghum stover, all of these have been to a certain extent being able to be utilized, but it's important to grind these and shatter the cane and create particles of less than 2 centimeters. We've seen peanut shells. But right now, I'm still just getting feedback from growers to look and seeing how some of these are successful. Now,
what do you think of wood chips? Because that's what we use a lot in our.
The issue that I find with wood chips is they absorb and they evaporate water slower, and they don't. That's part of the reason why I haven't been real enthused about wood chips. We can get a faster response if we're trying to control the moisture with a large surface areas and so on. It may have an advantage if those wood chips in which the bacteria and activity are occurring on the surface of them, like we see in some commercial composting, and it may create a different environment that we don't see when we use sawdust. So in general, I haven't been enthused about it, but I can potentially see the possibility that there can be some success. One of the other issues with composting is what is the carbon-nitrogen ratio of the bedding. We use sawdust and shavings, and carbon-nitrogen ratio is in the range of 2 to 700. And when we looked at all of our barns, we are primarily, when we are managing in this 45 to 55%, we are optimum carbon to nitrogen ratio that we see and learn about in composting. But when we start using beddings that are like 60 to 70, this curve starts moving down. And the experience I've had with soybean straw and peanut shells, we get carbon to nitrogen ratios that are low, and this is when we start really seeing the ammonia being formed, and when we see the smell of ammonia going into barns, because this is getting in the region where the carbon to nitrogen ratio is low enough that ammonia is being formed and released. So in this particular case, ventilation of the barn to at least keep it down for cows and them laying on it and exposed to some of this ammonia becomes an important issue. Finally, the last slide I want to show is the variation of plant nutrients that we found in a bed in which it was around 1 meter deep, and we dug through the depth of it and sampled it to look at how the variation in nitrogen, phosphorus, and potassium changed. In terms of phosphorus, it didn't vary too much, but there was a part of the depth to where potassium and nitrogen were higher at about mid-depth. And the reason why these were higher was this is the part of the bed that was on the surface during the summertime when we weren't adding a lot of bedding, and we weren't diluting out the plant nutrients with bedding. In particular for us was this low carbon, high carbon to nitrogen ratio biomass. So for potassium and nitrogen, we did see some variation as much as 30% higher for that part of the bedding when it was in the surface in the summertime. So that's what we had found. So I know you've asked a lot of questions, but are there any more questions that I can answer at this time?